Swayam Prabha. Digital India. Educated India.
Hello, welcome to this lecture on implementation of k-means algorithm in R. In the previous lectures, Professor Raghu would have given a brief introduction about this k-means clustering algorithm and the mathematical details of how this k-means algorithm works. In this lecture, what we are going to do is to introduce you to a case study which we use as a means to explain how k-means algorithm can be implemented in R. First, we will start with the problem statement of the case study, followed by how to solve the case study using R. As a part of the solution methodology, we will also introduce the following aspects, such as how to read the data from .csv file, how to understand the already read data which is in the workspace of your R, details about this k-means function, and how to interpret the results that are given by this k-means function. Let us first look at the case study. We have named this case study as clustering of trips. The reason will become clear when you see the problem statement. Let us look at the problem statement of the case study. An Uber cab driver has attended 91 trips in a week. He has a facility in the car which continuously monitors the following parameters for each trip, such as trip length, maximum speed, most frequent speed, trip duration, number of times the brakes are used, idling time, and number of times the horn is being honked. Uber wants to group these trips into certain number of categories based on the details collected during the trips for some business plan. They have consulted Mr. Sam, a data scientist, to perform this job, and the details of the trips are shared to him in a .csv format file with the name tripdetails.csv. This is a problem statement. Let us look how to solve this case study using R. So, to solve this case study, first we need to set up our RStudio workspace. You need to copy the file which we have shared with you into the working directory and clear the variables in the workspace. You can set the working directory using the set working directory command, and you can pass the path of the directory which contains this data file as an argument to the set working directory function, or you can use the GUI as we have specified in the R module to set the working directory. And this command here removes all the variables that are in the workspace and clear the R environment. You can very well use the brush button to clear all the variables from the environment. The next step is to read the data from the given file, and data for this case study is provided in a file with name tripdetails.csv. If you notice, the extension of this file is .csv, which means comma separated value file. In R, to read the data from a .csv file, we use read.csv function. Let us look what does this read.csv function takes as an input argument and what it gives as an output. Read.csv reads a file in the table format and creates a data frame from it. So, the syntax of this read.csv is as follows. Read.csv, it takes two arguments. The first argument is the file name and the second argument is the row names. We will see what these individual arguments are about. The file is the name of the file from which the data has to be read. Row names is a vector of row names. This can be a vector giving the actual row names, or a single number specifying which column of the table contains this row names. So essentially the syntax is read.csv, the file name, and if you have a column which specifies the row names, you can give that particular column as row names. In this case we have the first column as the row indices, that is the reason why we have given this row.names as 1. Let us see how to read the data from this tripdetails.csv. The data from this tripdetails.csv can be read by executing this following command here. I am using read.csv command and I am trying to read the data from tripdetails.csv, and I know that in the first column of the CSV file I have the row names. Therefore, I have specified row.names as 1, and this is the file name from which I want to read the data, and assigning the data which is read from this read.csv to the object called tripdetails. As mentioned in the help of read.csv, it reads the data from this tabular format and then assign it to an object called tripdetails, which is of type data frame. Once you get this data onto your R environment, you can view the data frame using view function. Notice this is capital V, and once you run this command, it will pop up a tabular column in your editor window which shows the variables in the data frame and the number of entries in the data frame. In this case we have 7 variables and around 91 entries. This is how you can view the data frame once it is loaded into your workspace. So to make it very clear, we have the 7 variables and there are 91 observations in this data frame, and the 7 variables are trip length, maximum speed, most frequent speed, trip duration, brakes, idling time and honking are noted for each trip. Now that we have seen how a data frame looks, it is time to see what are the data types of each variable that is available in the data frame. What is the way one can do that? One has to use the structure function to do that. The structure function compactly displays the internal structure of an R object. The syntax of the structure function is as follows: structure, and the argument it takes is an R object. This object is an any R object about which you want to have some information. Now let us look at the structure of the data frame which we have extracted from the tripdetails.csv. The data frame which we have extracted from tripdetails.csv is trip details, and I am passing that data frame as an argument to this structure function. When I execute this command, it will show that trip details is a data frame which contains 91 observations of 7 variables, and the 7 variables are trip length, maximum speed, most frequent speed and so on, and correspondingly it gives what is the data type of these variables. If you can notice, all of them are integer type data variables. Keep this in mind because the k-means wants all the variables in the data matrix as the numeric variables or integer variables. We will see that when we discuss about the k-means function as we go along. Now structure gives you type of the object and variables that are there in the object and their data types. There is another command which is summary, which gives you the 5-point summary of the numeric variables. This is the function summary. Summary function is a generic function used to produce result summaries of the results of various models and 5-point summaries of numeric R objects. The syntax for the summary function is as follows: the summary function takes one argument which is an R object. This object is again any R object about which you want to know some information. Let us see the summary for our data frame trip details. When you execute the summary command on your data frame trip details, it will give you 5-point summary for all the 7 variables of your data frame. Now let us look at our primary task of implementing k-means clustering on the data frame. So we have been given this data set of trip details and we have to segregate these trips into clusters. We are seeking an answer through the k-means clustering algorithm. If you would have noticed in the data, the trips are not labeled as short trip, long trip and so on. This means the data what we have is an unlabeled data, and when one wants to learn from this unlabeled data, one has to go for unsupervised learning techniques. K-means is one such unsupervised learning technique, and this k-means clustering in R can be implemented by using this k-means function. Let us look at what this k-means function takes as input arguments and what does it return. K-means takes several input arguments. I have given few of the important arguments here. X stands for numeric matrix of data or the objects that can be coerced to a matrix, and this centers we can either give the number of clusters you want to generate out of this data, or you can give a set of initial cluster centers. So if you specify this k as a number, let us say 3 clusters, what it does is it will choose a random set of distinct rows in this numeric matrix X as the initial centers. And as you know, k-means is an iterative algorithm. You can set a maximum iteration limit using this itermax argument. The k-means clustering algorithm depends upon the initial cluster centers. This option here, nstart, will help you to specify how many sets of different cluster centers has to be used to come up with the model. And finally, the output argument is object, which returns an R object which is of class k-means. That is basically is a result of a function which is as shown here. That is exactly what we have here. When you execute this command, it will take the data matrix and it will take number of clusters you want to build from this data and returns you a k-means R object. Let us now implement this k-means algorithm on our data. This is what we are essentially doing. We are clustering our data using the k-means, and we can see what are the details that this k-means gives as an output. This command here takes this data frame trip details, and this argument here specifies I want to divide the data into 3 clusters. When I execute this command, it will divide the data into 3 clusters and it will assign the result as a trip cluster R object, which is essentially a list. Let us see what information does this trip cluster has. Trip cluster has the following information. The first line essentially gives you, it has clustered the data into 3 clusters which are of sizes 46, 15 and 30, and if you sum this up, you will end up with your total number of rows in your data frame, that is 91. You can verify that, and for each variable it will give the means of the clusters. So because you wanted to divide the whole data into 3 clusters, the first row is the cluster 1 information, where the mean of the trip length is 19.9 and the mean of the maximum speed is 48.21 and so on. Similarly, the lines 2 and 3 represents the information about the cluster. So what can one infer from this cluster means? You can actually see, for example, mean trip length is 19.9, I can actually say that this is of shortest trip, and if the mean trip length is 174, I can treat this as a long trips. So this information can essentially help the people who wanted to do this analysis and then categorize these clusters into meaningful information depending upon the problem they are looking at. The next piece of information that this trip cluster contains is, it will say among 91 rows what does each row belong to. For example, look at here, the first element, that means the first row, belongs to the cluster 2 and the second element belongs to the cluster 3, third elements belong to cluster 2 and so on. It will identify each row into one of these clusters, and as you know, k-means is a hard clustering algorithm. That means each point has to be allotted to any of the clusters and no two clusters contain a similar data point, otherwise you cannot have a single data point belonging to two clusters. This trip cluster has some more information which is known as within cluster sum of squares, and if you see, this contains 3 elements. That means how much is the variance in each of these clusters is what this within cluster sum of the squares gives us. The lesser the variance, the good are the clusters, and it will also give what are the other components that you can look from the trip clusters. Essentially, when you build a k-means algorithm, it will give you the following information: how many clusters it has built and how many data points are there in each of these clusters, and what are the means of each of these clusters, and how are each points are categorized into one of the 3 clusters which you want to build, and the other information. So biggest problem with this k-means algorithm is to figure out what number of clusters has to be given. So there is one method which is called as the elbow method, which can help us to calculate the optimal number of clusters k. For that, all you need to do is you have to write one for loop which does lot of k-means algorithms and get the metric which is within sum of squares, and when you plot this within sum of squares with the number of clusters, you will find out after certain number of clusters the decrease in this within sum of squares value is low, where you say, look, this is the optimal number of clusters into which your data has to be divided. Let us illustrate this code line by line. I am assigning a value of 10 to this k max and I am pre-allocating a memory which is, so this many number of clusters is there and I am repeating NAs for this many number of times. This is within sum of squares value. Essentially I am creating a vector with NAs which is of the size 10 by 1, and I am initializing an empty list for the number of clusters. This for loop will run from 1 to number of maximum clusters, that is in this case it is 10, and for each value of I this k-means algorithm is implemented. The objects are being stored into this drive classes, and in the drive classes the total within sum of squares distance is being allocated into this WSS of I, and the size of the cluster is allocated into the components of the list which you have created. So once this for loop get executed, you will get a vector of the within sum of squares errors and a list of the number of clusters. Now you can plot that with number of clusters in x axis and within sum of squares value in y axis, and type is equal to b represents both line and points has to be there, and PCH is equal to 19 specifies the symbol that has to be used along with the plot, and x lab and y lab has their normal meanings which are x label and the y label. Let us look at the plot. So this is the x axis which is number of clusters, which is varied from 0 to 10 because the maximum number of clusters we had is 0 to 10, and this y axis is total within sum of squares values with respect to trips, and if you can see, this total within sum of squares value drastically decreased when one moved from one cluster to two clusters and from two clusters to three clusters, and after that the decrease in total within sum of squares clusters is not much when compared to the earlier ones. That is the reason why I can choose this k is equal to 3 as my optimal number of clusters. In summary, we have seen that k-means algorithm is an unsupervised learning algorithm. That means we have the data which is not labeled. In these cases we have to use one of the unsupervised learning algorithms. In this case we have used k-means algorithm, and we have seen how to implement this k-means algorithm in R, and we have seen one method to find the optimal number of clusters for k-means, which is elbow method. Thank you.